There are millions of organic compounds. Yes, like a lot of them are there. But how are scientists able to classify them? And why is it so important for us to classify them? But before we jump right into it, just imagine this. You enter a library, and there are a lot of books, thousands or millions of books in the library. There are tables also there, and there are just one or two shelves. And not the rest of the books are just scattered on the floor. And even the shelves that are available, the books there are not labeled. So if you have to find a single book in these thousands of books, do you think that's going to be easy? No way. It's going to be extremely difficult for you to locate just one book. That's the same thing when it comes to organic compounds. If scientists do not classify organic compounds, it will be difficult for us to locate a particular organic compound or describe it to someone. So that's what we'll be doing in this lesson, classification of organic compounds. When it comes to classifying organic compounds, there are certain criteria that are used when it comes to classifying organic compounds. Criteria. And keep this in mind. A particular compound can belong to multiple groups or classes. So let's start with the first classification. Hydrocarbons and hydrocarbon derivatives. Good. Hydrocarbons. Let's look at this example. The compound you see is known as a methane. Methane. You can see that there are only carbons and hydrogens present. So when it comes to classifying organic compounds, the very first umbrella you can classify them in is 2, based on the presence or the atom that is or are present. So if the atoms present in an organic compound are only hydrogen and carbon, then we have hydrocarbon, right from its name, right? Yes, the name hydrocarbon. So hydrocarbons have only hydrogen and carbons present in them. And as the name suggests, hydrocarbon derivatives are derived from hydrocarbons. How? It basically means that hydrocarbon derivatives start off as hydrocarbon, and one or more of its hydrogen is replaced with another element. So you can see that methane has 4 hydrogens around the carbon, but methanol has 3 hydrogens, and one of the hydrogens is replaced with an OH group. That makes it a hydrocarbon derivative, meaning it is derived from hydrocarbon. Our next example will be ethane. Ethane is a hydrocarbon. Why? It contains only carbon and hydrogen atoms, if you take a very close look at it. But look at this, ethylamine. Ethylamine is more like an ethane that has lost 1 hydrogen, and the hydrogen is replaced with an amine group and NH2 group. So I think you get the point. Hydrocarbons and hydrocarbon derivatives. Hydrocarbons have only carbon and hydrogen. Hydrocarbon derivatives have one or more of the hydrogen replaced with another atom or group of atoms either than with hydrogen. Got it? I think there's one more example. Benzene. Only carbon and hydrogen present. Then we have what? Phenol. Phenol is more like a benzene, but 1 hydrogen is replaced with an OH group. So basically, that's the idea of hydrocarbon and hydrocarbon derivative. Now let's consider aliphatic and aromatic compound. Now we've gotten the bigger umbrella. Either they have carbon and hydrogen, or maybe one of the hydrogen is replaced with something else. What about aliphatics? Let's look at this. Aliphatic compounds are basically links or connections of carbon atoms to form either straight chain or branches, or better still, any organic compound that does not have an aromatic ring present in it. And when we are talking about aromatic ring, one of the things that should come to your mind is benzene. Yeah, benzene should come to your mind. We'll take a look at benzene in some few minutes or a few seconds. So this is an aliphatic compound. Why is this one aliphatic? Because it is an open chain. So keep that in mind. Aliphatic organic compounds are organic compounds that are considered to be open chain. And the open chain simply means they do not form a ring. That is one side of aliphatic aliphatic compounds. So it's either they are open chain, or even if they have rings, the rings are not aromatic. Yeah, that's the point. Now let's pick the first side, open chain. The open chain can either be straight chain or branch chains. So let's look at the straight chain again. So you can see that this is butane, and butane has 4 carbons connected to form a straight chain. But look at this. We have 2-methylpentane. We have 5 carbon atoms linked to form a chain, and there's 1 carbon sticking out of the main chain. This makes this a branch chain. But whether it's a branch chain or a straight chain, it's still aliphatic because it's an open chain. It doesn't form a ring. I hope that's clear. Another thing to consider when it comes to aliphatic compounds is the fact that an aliphatic compound can form a ring, but will be considered aliphatic if that ring is not a benzene ring. We'll look at what benzene ring is in a second. If that ring is not a benzene ring, or that ring is not an aromatic ring, the criteria for considering a particular ring to be an aromatic ring will be considered in future lessons. But for this level, always look out for a benzene ring. And this is a non-aromatic ring, which is cyclobutane. So this also falls under aliphatic. Then we have aromatic. This is what I've been referring to as benzene for all this while. So there are a lot of organic compounds out there that have this benzene ring in them. That makes them aromatic compounds. So they form rings. And back in those days, the few aromatic compounds that were formed or found by scientists tend to have nice aroma. That's how come they give them the name aromatic compound. Only for them to realize that some of them qualify to be aromatic compound but do not have that nice aroma. So the criteria has been changed, and we'll be discussing that in future lessons. Then we also have phenol. So you can see that phenol has a benzene ring, but one of its hydrogen has rather been replaced with an OH group. So this makes phenol also an aromatic ring. So for your level, just keep this in mind. Benzene ring should be one of the determining factors for you to know whether a compound is aromatic or not. But I want to point out one thing, really interesting. If you look at cyclobutane, it is also what? A hydrocarbon. So we can refer to this as an aliphatic hydrocarbon. Good. And benzene is also a hydrocarbon, but phenol is not a hydrocarbon. Let's move on to the next classification. Saturated and unsaturated compound. What exactly are they? For us to classify organic compounds as saturated or unsaturated, it has to do with the presence of either a double or triple or single bond. So let's look at an example really quick. For saturated compounds, for this is butane. You can see that it has only carbon and hydrogen. That makes it a hydrocarbon as well. So this is a hydrocarbon. And you can see that it's an open chain. That makes it aliphatic. And it is also saturated. So it is a saturated aliphatic hydrocarbon. Interesting fact. So this is butane. What makes it saturated? For us to see if an organic compound is saturated or not, we have to check the carbon atoms. If the carbon atoms present have only single bonds around it, all the carbon atoms have only single bonds, then know that that compound is saturated. What it means is that it has the maximum number of hydrogen it can actually accommodate. Yes, let's put it that way. So just look out for single bonds around all the carbon. If you find that, then that organic compound is saturated. Let's look at the next one, which is unsaturated. If you look at this is 1-butene. It's an alkene. You can see clearly that some of the carbon atoms have single bond, but we have 2 of the carbon atoms that do not have only single bond. There is a double bond found between 2 of the carbon atoms. Because of this double bond, this compound is an unsaturated compound. So unsaturated compounds have double or triple bonds. So you can see this one has a triple bond. What the double and triple bond means is there's room for other atoms to be bonded. So for the double and triple bonds, the double bond, one of them can be broken, and for the triple bond, either one or two of them can be broken. So there is an extra space for other atoms to be bonded. That means it's unsaturated. It is not saturated. So the bottom line, saturated compounds have only single bonds around them, and unsaturated have only, or maybe a double or a triple bond. I think that makes sense to you. If so far this doesn't make any sense to you, just just leave it in the comment section. Yeah, we'll do our best to address that for you. So this brings us to the end of classification of organic compounds. So we've classified organic compounds into hydrocarbons and hydrocarbon derivatives, aliphatic and aromatic, and then saturated and unsaturated. Yeah, so that's what you've just done. If you find this lesson helpful, subscribe to the channel, put us on post notification, and share this lesson with other students, who benefit from lessons like this. For our fifth lesson, lesson number 5, what will we be discussing? We'll be discussing alkanes. Yeah. Now we are starting really quick. Alkane, we'll look at the general formula, and then we'll look at more interesting details. So do not miss this lesson. Subscribe to the channel, and if this lesson is ready, click somewhere so that you watch our next lesson on alkanes.